This is section 3.4, proofs with perpendicular lines. So the first thing we're going to talk about is distance from a point to a line. The shortest distance from a point to a line is the perpendicular segment from the point to the line. So think, if we want to go the shortest route somewhere, we go directly there. We don't kind of go diagonally. We want to go directly perpendicular to that line. So we're finding the distance from point A to line BD. So we have to choose, are we going to use AB, AC, or AD? Well, we want the perpendicular one, so we're going to do AC. So we need to find AC using the distance formula. So x2 is 1 minus -3 squared plus -1 minus 3 squared. That gives us the square root of 4 squared plus -4 squared, just 16 plus 16, which gives us the square root of 32. And we can use our calculators to find that the square root of 32 is about 5.7. So the distance from point A to line BD is about 5.7. A perpendicular bisector is a bisector that is just perpendicular to the segment. So when we talk about bisectors, remember that means it cuts it in half. And now we're just saying a perpendicular bisector is a special type of bisector that meets it at a right angle, cuts it in half at a right angle. So in this case, N is a perpendicular bisector of PQ. A few more theorems for you. The linear pair perpendicular theorem. If two lines intersect to form a linear pair of congruent angles, then the lines are perpendicular. So if we think a linear pair means it forms a line, which we know is supplementary. If we have two lines intersecting to form a linear pair of congruent angles, so that means this is x and this is x, we can say x plus x equals 180, 2x equals 180, so x has to equal 90. Well, a 90-degree angle is a right angle. That means this one's also a right angle. They're congruent, and they're a linear pair. So since we have that right angle, they have to be perpendicular. The perpendicular transversal theorem says that if in a plane, if a transversal is perpendicular to one of two parallel lines, then it's perpendicular to the other line. So what this is saying is if you have two lines, and you know those lines are parallel, and you have a transversal, and you know that transversal is parallel or perpendicular to the first line, this is saying that it also has to be perpendicular to the other one. So if you know this, then you can conclude this. And then the other one, if two lines are perpendicular to the same line, then they are parallel to each other. So it's kind of the backwards version. So we have two lines and a transversal. We know that it's perpendicular to both of these. So that means that if it's perpendicular to both of these, then we can conclude that these two lines are parallel. So doing a proof, we're given that H is parallel to K and that J is perpendicular to H. We're trying to prove that J is perpendicular to K. So our first line is always given, so H is parallel to K, and that J is perpendicular to H. Next, using the definition of perpendicular lines, I want to make a statement about angle 2. Well, what does it mean for be perpendicular? That means that the measure of angle 2 is equal to 90 degrees. Perpendicular means they meet at a right angle. Right angles are 90 degrees. Using the corresponding angles theorem, I want to say, okay, what angle is corresponding to angle 2? And I know that's angle 6. And I know that corresponding angles are congruent. So I can say that angle 2 is congruent to angle 6. And by the definition of congruent angles, remember we can go from saying they're congruent to saying they have equal measures. So the measure of angle 2 is equal to the measure of angle 6. And then transitive property or substitution, either one. I know that the measure of angle 2 is 90 degrees. So I'm going to say 90 degrees equals the measure of angle 6. Well, if angle 6 is 90 degrees, then that means J has to be perpendicular to K.